So thank you, Kevin, for the good introduction. Actually, I think I came at Copenhagen.js exactly 1 year ago and presented how we build the electricity map. So I'm going to talk a bit less about that and a bit more about the sustainable development goals that we're having and about climate change, and give a sneak peek into the thing that we're building later on, and hopefully after we can have a discussion, and hopefully also I can inspire other people that want to do good using their coding skills. So first of all, a bit of the outline that I mentioned, SDGs, what we're doing here at Tomorrow in the small company that I founded 2 years ago, and how we all can help contribute and fix this thing, hopefully. A little bit about myself, just very briefly. I'm half French and half Danish. I have an engineering background. I did a lot of math. Spent a bit of time at IBM Research and also at Google later on. So I did a bit of energy, then I did something that has nothing to do with energy. I was in a small startup that basically tried to put AI into your pocket, replicate Google Now. And then I thought we have much bigger problem in the world to solve compared to just optimize a bit our workflows, hence why I started this company. So if you look a bit about the challenges we're having, the United Nations in 2015 came up with all of those goals, which showcase basically a map to having a better world. And today we're going to focus only on a subset of them, basically the ones that relate to having clean and affordable energy, but mostly the clean parts, about the climate action, which is about climate change, and a bit about how we can responsibly consume goods or take better decisions and consume better as citizens. The challenge we're facing right now is basically plotted on this graph, and this is a long time series. If you look here, it's minus 6,000 years. You normally don't see those series go that far back. And this is the temperature anomalies you see. So you see that the Earth was cooling down and we were ejected out of this small ice age with a tremendous increase that you see here, which is the increase of temperature since the Industrial Revolution. And the only thing to remember from this graph is that what is worrying is not so much that the temperature changes, because it has changed. The only thing to remember is that we've been having a change of 1 degree in only a couple of decades, and this is something we haven't seen before. And if you look at the complicated equilibrium that the Earth is having in terms of energy balance and weather and so forth, if you just change the temperature by 1 degree in a time span as short as a couple of decades, that's a big change for Mother Earth, basically. And where does this change come from? We all have heard about the CO2 stories, but this is just, again, a time series from a very long time. It goes to minus 40,000 years. And on our website, you can go back to 800,000 years if you really want to see the whole history. And you see this huge spike, which is here, which is like the spike that has happened in the last 200 years, basically, or since the beginning of the Industrial Revolution. And again, if there's one thing to take away from this slide, is that CO2 stays in the atmosphere for centuries, between centuries and millennia. So it means that everything we're emitting right now and putting into the atmosphere, it's debt that we're leaving to our children, our grandchildren, and so on. Unless we suck it back, but there's no current viable technology to suck the CO2 back from the atmosphere. So when people tell you the emissions are stabilizing, it's good, well, no, it's not good. Emission stabilizing would mean that this slope continues constant, and we're continuing to go straight up to the roof. So we need to get to zero emissions, and all the reports you can see on those things basically say we need to get to zero emissions by 2050, else we get really in deep shit by the end of the century. So this is a bit the challenge that we're facing. Now, all of this CO2 emissions, most of it, is actually 2/3 of it, comes from all of our energy usage, and all of our energy usage comes from the fossil fuels. So the fossil fuel is this brown part you have on top, and this is a series that shows the last 35 years where the energy has been coming from. And so even though in the news we see a lot of wind turbines and think the world is getting greener, the share of it is actually still exactly the same. It's still 85% of fossil fuels in all the energy that we're consuming. And still the challenge that we're having in the next 30 years is that we need to take this big chunk and find something else, a substitute for it that doesn't emit CO2. So hence the question of how do we get rid of those fossil fuels, right? And before I answer this question, I want to showcase a bit of a video that gives a bit of ordinance of magnitudes of energies so we can start figuring out how to answer that question.
ready? Everything is okay with the handlebar, seat post, shoes, seat. Okay.
Everyone on positions now. We're getting ready for take. And remember that when Robert loses power, the toaster will pop up.
You can feel like taste of blood in your mouth. Want to lie down?
My legs hurt. Ja, det.
Put them up. The monster is beaten.
Nobody can believe if you do it at the breakfast inside the toaster. Nobody can believe how much work it is to toast it. Huh?
No, no.
I know it now. It's crazy. It's fucking hard.
Thank you. Okay.
I want a picture with you, Robert.
Nu kan alla ta selfies med honom.
Dina ben så smala ut. Your looks look very tiny.
All right, and if you think about why it's so hard to get rid of fossil fuels, you can think about how much energy there is in just 1 liter of oil. If you take 25 professional cyclists, and I'm not taking the sprinter as the guy you just saw, just an average Tour de France cyclist, there's around actually a 300 watts, I think. How much is it? So if it's 400 watts in average, and you have 25 of them, that gives you 10 kilowatt hours for an hour, and that's exactly what you have in 1 liter of oil. So you have those 25 guys cycling for 1 hour and exactly the same as 1 liter of oil. Look at the price. I don't know how much you're gonna pay those cyclists, but you know, even like 10, 100 euros an hour, whatever, you will get to orders of magnitude compared to just the price of oil. And then you have people complaining about the price of that energy, but it's actually amazing how much you can get for only that. The second thing is that it's also completely portable. You just put it in a bottle, you take it with you, and then you have this energy with you, right? It's not the same thing as if you have a wind turbine, you need to put it in a battery and then manufacture battery and so on and so forth. So this is why it's so hard to get rid of those fossil fuels. And if you make a back of the envelope calculation, what you end up with is that every day on Earth, we're using a lot of energy per person, and the equivalent is approximately that we have 15 guys cycling, you know, for a whole day for us to use the whole electricity energy that we're consuming. And so the thing to understand is that if we really want to remove those 80% fossil fuels, we need to figure out a way to generate an insane amount of electricity without all the oil, the coal, and the gas that we're having. So this is the challenge that we're having, and this is why we haven't really figured that one out yet. So what do? And the thing that the trajectory the world has set to take right now is just to electrify everything and say, instead of burning oil, gas, and coal, what we do is that we just generate electricity, and then that electricity, we put it in planes that are gonna fly with electricity, cars, electric heating, electric everything, basically. The only thing to remember is that what about this electricity? How is it itself generated, right? And unfortunately, right now in the world, you still have 2/3 of that electricity that comes from coal and gas right now. And I show this picture, show an idea of the scale of this, because you have, so this is a coal mine in Germany, and you can see maybe here, this is a small tractor. So it shows you the scale of this immense machine. And yesterday there was just a small video that was released by Sandbag, actually, that shows all the coal power plants in Europe and how they diffuse pollution inside the atmosphere. And you can see them diffuse over the whole Europe. And this is buzzing quite extremely since yesterday. Hence, I thought it was cool to show it here. So in the end, if you want to have low carbon electricity, you have 3 strategies. You can have nuclear, which is doesn't emit any CO2. However, it has the obvious drawback of generating those radioactive waste that you have to handle. You can have hydro-powered electricity, but what you need is mountains from where to make the water fall. And so, for example, in Denmark, it's kind of complicated to build a mountain and then have this water fall down from. And then you have wind and solar, but obviously the problem with wind and solar is what you do during the night when there's no sun, or during periods of times when there's no wind blowing, right? And this is where we started our work at Tomorrow, the company that I founded, where we built this thing called Electricity Map, and it basically shows you how green is your electricity right now, and the column on the map basically shows you how green it is. And so it takes into account the imports and the exports. Well, actually, I think I'll show you a quick demo of it, because it's always funnier to look at how it is exactly right now. So you can go on it, it's just electricitymap.org. Now zoom in on Denmark. And so all the small arrows you can see showcase the flows of electricity. So basically, you can see that right now Denmark is importing from Norway and from Sweden, over here, and also from Germany. And you can see, for example, this area that we're importing from both sides, we're exporting to Germany. And if I click here, then you have all the details about how much the wind blows. So currently it doesn't blow that much, because if it blew, it would be the whole way to the top here. There's a lot of biomass right now, so we're burning waste and basically wood pellets in order to heat the homes on this cold day. And then we're importing here from DK1, which is West Denmark, and importing some green electricity from Sweden that makes the Danish electricity look greener. And so we have this data now for a lot of different countries in the world. And I came last year to explain exactly how we built this thing, but just a few words is that part of it is open sourced, in the sense that you can see here, this project is open source, so contribute by adding your territory. So if someone comes here and says, well, actually I have data for the French Guiana here, then you could submit a pull request with a small script that fetches the data, standardizes it, and then it would appear suddenly on the map. And we started 2 years ago with just a few countries, and now we have all of those, and that's exclusively thanks to the community that has been helping on building this. So this is a view of the GitHub repository. So basically just have a Python script, one for each area. And then if you know where there's data, you just submit a pull request, put it there, and then it will automatically pop on the map. We did a time lapse of this thing. And so you can see that this is the wind currents. And you can see all the countries that are basically blinking as the wind comes over it. You can see England and Denmark, as soon as there's a big wind gust that comes over it, the country turns green. And of course, this starts to ask the question of, well, shouldn't we be consuming the electricity when it's greener? I mean, when the wind is blowing instead of when it's not blowing, because that's only the real way we can become truly green all the time. And hence, how we started, earning money in the company, we built this API that predicts in 24 hours ahead how is the electricity going to be, where is it going to come from, how green is it going to be. And then we sell that to any manufacturer that wants to integrate it in a smart system. So you think about an electric vehicle, you come home at the evening, you plug it in. Well, obviously you want it to charge at the right time and not exactly when you plug it in. So if it can be delayed a little bit, then that helps. We're working with data centers also. They have huge capacities in computation. So you have your batch shop, you're just scheduling in the evening. Well, they could maybe do something smart and move it to the place where the wind blows or at the time where it blows. Those are some of the things we're doing. And a bit of what we're working on right now, going beyond electricity, because electricity is only a small portion of our footprint. So if you look at actually our footprint, you can look at this very complicated graph that shows you All the greenhouse gases on the right side, on the left side you have all the sources. So you see all those fossil fuels, basically all the 2/3 brown chunk that you have to the left side. And what you want to do is understand, well, basically in everything that I do in my daily life, what are the good choices I can make? What are the things that really are good compared to the things that I shouldn't be caring about, right? And so what if you could have automatically your carbon footprint on your app and know exactly what I've done of good things and what I could do better. And so this is exactly what we're building. So I show you a small screen capture I did today of the prototype we're having that we built on React Native. So the idea is that you have a bunch of, I don't know if everyone can see, but I'll describe it. You have a bunch of connectors here. So basically third-party data providers that you can activate. And here there's one of them that's called TripIt. And TripIt is a service that's used by companies to aggregate all the flight details of people. So basically, what we do here is that I just connect with my account, and then it will look in my emails and fetch all the emails and that I've had that correspond to travels, so airplane bookings or train bookings. And then it goes back, it collects all of it, and then I have a diary where I can see exactly the history of everything that I did, all the associated footprints, and that's really the first step that we're having here. So the app that we're currently building is something where, first of all, you connect a third-party system. So it could be TripIt, it could be Uber, for example, in this example. So it means every time you take a ride, it pops into the app. You discover and understand exactly what is the relative scale of the different things. And then you can start compensating. So basically you will pay to invest in a carbon negative project, a project that will try to do something good, install some wind turbines, or do other things, even suck out carbon from the atmosphere. And we'll enable you to do that directly from the app. So one use case we finally finished integrating is the Reisecode. So every time you check in and you check out from it, we directly put it in the app and then you know how much carbon was emitted in your commute. We're currently working on a second thing where there's a company called Storebox that is gathering all your digital receipts from every time you go to Danish supermarkets. And so once you have this as a PDF, you can parse it. And then you can figure out, this is broccoli, and I know the footprint of broccoli, so I can just put it inside the app, right? And so we have some NLP models that are currently running, and now we're just finalizing the partnerships in order to have this in the app. So it means every time you'll buy some food, bam, it will directly come into the app. And the last thing is also on electricity, of course, because we know the footprint of electricity, and Barry's going to talk a little bit about your personal consumption of electricity. But basically, if we put those two together, we can show you actually you used electricity at the right time or at a bad time and showcase you the feedback in the app. And of course, electric vehicles will also be there because those are so fundamental. One thing that we're replicating from the electricity map, and hence also why I'm here, is that we're defaulting to open in a sense that a lot of the things in the app will be open source. And we already have a repository where we put all the small connectors that we made. So the Reisecode, for example, is already implemented in JavaScript in a repository. And the idea is that if any one of you wants to hack something together or integrate it with a third-party provider that maybe is not used a lot, but it means a lot to you and you want it in the app, then come talk to me or join the repository, and then we can build this together. And one last thing is that everything is built with privacy in mind, in the sense that everything runs on the device, on React Native. So it directly fetches the data from the different providers, from Uber, but we don't have a cloud. So there's nothing to hack, and we can't sell the data to anyone because we don't have it. And we're actually also thinking of making the whole code of the app open source, so you don't have to believe me, you can just go and check it in the code if you want to. So with that said, if you're interested in either working with us, we're starting to hire slowly. We're still a small, lean startup. And also if you want to join the beta, we're looking for very committed people that tolerate, apps that are still in a very early stage. But if you're interested, come talk to me. And else, I guess we'll have a chat afterwards. Thank you.